All right, welcome. Today, we are diving into a fundamental force of nature that's, believe it or not, constantly at work all around us. It's the reason a hot air balloon can soar through the sky, and it's the engine that literally drives our planet's weather. It's called convection, and once you get it, it kind of changes how you see the world.
So, let me start with a puzzle you've probably noticed yourself. In any house, right? Why does the top floor always feel like an oven in the summer, while the basement stays nice and cool? It seems like just a weird quirk, but what's the actual science behind it?
And no, it's not magic, even though it might feel like it. What you're experiencing is this incredibly powerful and totally invisible process of heat transfer. It's a fundamental principle that, once you see it, you'll start noticing it absolutely everywhere.
So what is this process? Well, it's called convection, and it's one of the main ways that heat energy gets around, constantly moving from one spot to another. So what is it exactly? Well, convection is just heat transfer that happens when a fluid, and in science, remember, a fluid means both liquids and gases, when that fluid physically moves. The fluid itself basically becomes a vehicle, carrying heat along with it for the ride. Okay, let's zero in on what makes convection so unique. First up, it's a huge player in how heat gets around. Second, and this is the big one, it only happens in fluids. You're not going to see convection in, say, a solid block of steel. That's because it needs the actual movement of matter. The air or the water itself has to be able to flow.
Okay, so we know what it is, but how does it work? I mean, what's the engine that drives all this movement? I like to call it the density dance, and it is the absolute key to this whole thing.
Yeah, this is the central question, right? A pot of water doesn't just start swirling around on its own. Something's got to kickstart that motion. So what's the trigger? What gets the ball rolling? The answer? Well, it all boils down to one simple but really powerful property of matter: density. You know, how much stuff is packed into a certain amount of space. This one property is the engine of convection. So here's how the dance works. When you heat up a fluid, its tiny particles get a ton of energy. They start zipping around like crazy, bumping into each other and spreading way out. Because they've expanded, there's now less stuff in the same amount of space, which means the fluid becomes less dense. Now, the exact opposite happens when a fluid cools down. The particles slow down, they huddle together, and it becomes more dense. And here's the kicker. In any fluid, the less dense stuff always rises, and the more dense stuff always sinks.
And that's the entire mechanism right there. It's a simple loop. The act of heating and cooling a fluid changes its density, and that change in density forces it to move. Hot, less dense fluid goes up. Cold, more dense fluid comes down. That's the dance.
And this constant cycle of rising and falling creates this powerful loop we call a convection current. You can think of it like a conveyor belt for heat. You heat a fluid from the bottom, it gets less dense, and it rises. As it gets away from the heat, it cools off, gets denser, and sinks back down, only to get heated all over again. It's this continuous circular flow that moves heat around so effectively.
Okay, this all sounds great in theory, but can we actually see it happen? Oh, absolutely. Let's make this invisible engine visible.
You know, the best way to really understand a science concept is to just see it in action for yourself. And lucky for us, there's a classic experiment that lets us watch this entire density dance unfold right before our eyes.
So here's how you do it. You take a beaker of water, you drop a small colored crystal in there, that's going to be our tracer. Then you gently heat the beaker right underneath that crystal. Almost right away, you'll see this beautiful plume of colored water start to rise up. That's our hot, less dense water on the move. Once it gets to the surface, it spreads out, it cools off, and you'll actually see it cascade down the cooler sides of the beaker, completing that whole loop.
That colored water just perfectly traces the path of the convection current. What was just an abstract idea a few minutes ago is now a visible, physical process. We're literally watching the density dance happen right there in a glass of water. It's amazing.
So we've solved the puzzle of the warm attic, and we've seen the proof in a beaker. But this isn't just some lab trick. This exact same process, this very same density dance, is what drives massive ocean currents, what creates winds and giant storms, and it even causes the tectonic plates of our planet to drift on a sea of molten rock. The question isn't just where can you spot convection, it's where can't you?